Okay guys, here we are going to talk about an interview question which is called pair sum problem. Now what this problem statement says is we are given a sorted array and a sum, integer sum s. So what we have to tell is, can we add any two elements in this array to get that sum? So here the example that we have taken, if you see, the array is this and sum we are searching for is 144. So the answer we are supposed to give is, can we add any two elements in this array to give this sum 144? Now ideally if you see, then we can add 45 and 99 together. If you add these two values 45 and 99, what we are going to get as a sum of these two is, it is going to be 144. But this we have to tell programmatically, because we can give any sum in this array. For every given sum our program should work. That's the goal. And this, if you see, this question has been asked by Google, Amazon, Flipkart, Carvale. These are the companies which have asked this question in their interview. And we have to solve this question in best time complexity that we can think of. Now, if we go with the approach in our mind, the first approach, the typical that comes to our mind is this, that we may say, let's go and try all the pairs in this array. When we say all the pair means, let's take 10 and consider all the pairs of 10. So 10 plus 23. So with 10 we are considering pair of 10 with every element. So 10 and 23. Then we can compare 10 and 45. This is another pair. So first pair is giving us 33. Second pair is giving us 55. Third pair if we take will be 10 plus 67. This pair is giving us 77 as a sum. 10 plus 99 is going to give us 109 as the sum. And 10 plus 103 is going to give us 113 as sum. And none of these sums are equal to the sum that we are searching for. And we are done with pairs of 10. So what we do is, next we start evaluating. Let's see, any pair of 23, does that give us a sum of 144 or not? So what we do is, we start with 23 and we start getting another pair sum. So when we take 23, we will not go with 10, because 23 and 10 pair is already evaluated. So we will start from the right side of 23. Let's say we do 23 plus 45. This sum we evaluate. So this sum comes out to be 68. Next we say 23 plus 67. This sum if we do, it comes out to be 90. Still not the sum we are searching for. Then we say 23 plus 99. This comes out to be 122. This is also not the sum we are looking for. Then we say 23 plus 103. What it will give us is 126. This is also not the sum we are looking for. So pairs of 23 are also done. Now we look at pairs of 45. So that's the next value. So let's say 45 plus 67. This gives us 2112. Right? So this is the sum we are getting. Now we say 45 plus 99. If we do this, then what we see is we get a sum is 144. So this is where we get our answer and we solve the problem. Right? But what we did in this solution is, we are considering all possible pairs in the array. So that is our first approach. Approach 1, we consider all possible pairs in the array. Now think about, if array is of size n, if size of array is n, how many pairs are possible? If size of array is n, then pairs possible are, 10 will have a pair with n minus 1 elements. Right? So 10 will have n minus 1 pairs starting with 10. 23 will have n minus 2 pairs, because 23 getting paired with remaining values. Same way 45 will have n minus 3. And 99 will have only one pair. It will be 99 into 103. Starting with 99 going to the right, we are saying there will be one pair. So these many distinct pairs are possible. If we add all of them together, this is going to give us n into n minus 1 by 2. And time complexity wise, like whatever number of pairs are there, we are evaluating all of them. Time complexity wise, what we essentially do is, we get rid of constant terms. So what we do is, we remove this minus 1, we remove this. Eventually we say this solution that we have come up with is order of n square solution. And in interviews, when these companies ask this question, they say this is an obvious solution that anybody can think of. What we need from you a better solution than this. So time complexity is something we are asked to optimize from here on. So we need to think of another approach that will work, and that is the solution expected in our interviews. Right? So we have to work out approach 2, and that is the crux, or that is the point of discussion for this video. Now, how do we optimize? Let's take an approach. This is a technique that we call as two-pointer technique. And this is a very powerful technique used in many array problems. So we can apply this to optimize many array-based solutions. We will talk about all those problems in our course, but pay attention to what this technique says. So what this technique says is, let's take the array 10, 23, 45, 67, 99 and 10. This is our array. It says try to analyze pairs in such a way that we are not going more than n times. And how is that possible? Two-pointer approach suggests, let's take a pointer here. When we say a pointer, it's just the index. So initially we are at 0 index, 0, 1, 2, 3, 4, 5. Let's take two integer variables, one starting from the beginning, another starting from the end. So this is what we have started with so far. And it says add first two elements, I and j, two elements at these indices. If you add 10 and 103, get the sum and see what that sum is. So this sum, if you see, is coming out to be 113. Now this is the interesting part of this approach. When we have taken this sum, compare it with the sum we are looking for. We are looking for a sum of 144, which is certainly greater than this. So we need to think of the next pair which will have a sum greater than 113, and that we can get by moving I forward. Think of it, the max possible sum so far we are getting is this plus this. Any values starting from here will be less than 103. So if we move j back, the sum we are going to get will be less than this, less than 113, because 103 was a bigger number and now we are reducing it. So we do not move j back, we move I forward. So that is what this technique talks about. So in first step, what we do is I moves from 0 to 1. This is what we bring. So that means in one step we have gotten rid of one element from the array. So array is reduced to n minus 1 now. In one step, one element is removed. Now this is I, this is j. Let's add these two elements. So we are adding 23 and 103. This sum that we see comes out to be 126. Again we compare with the target value we are searching for, which is 144. So 144 is greater than 126. If the sum we are looking for is greater than the value that we are getting right now, again we move I forward. We say let's get rid of this. So I comes to index 2. This is where I comes. Now again let's add 45 and 103. So 45 plus 103 will give us 148. This time there is a difference. The sum we are getting is greater than the sum we are looking for. So if this situation comes, if we move I forward again, I is going to increase only because this is a sorted array. It is going to increase, it is going to be more than 148. So this is the place where rather than changing I, we change j, we move j back. So when we are sitting at 45, when the sum is greater than the required sum, we are staying I here, we are keeping the I here and we are moving j back. So j comes back to this term. Now j is at 99, I is at 45. Add these two values, 45 plus 99, and we are going to get a sum of 144. Right? So we have found this sum, pair sum, in just n steps in worst case. Because imagine if these two elements were added to get the desired sum, we would have moved one more step and we would have found our answer. So this two-pointer technique that we are talking about, take I and j, I from 0 and j from n minus 1, and keep moving them, is helping us get the time complexity to order of n. So that means we can get the results faster. So both these approaches that we have discussed, we'll also convert them into code and quickly see what the code is going to look like for them. Right? So let's go with the optimized approach. which is this. So what we do inside this, we say int I0 j is equal to an minus 1, because the last index in the element will be the size of the array minus 1. Now what we do in this, we say let's write a loop. So we could have done this inside the loop. So let's say for int I0 j is equal to this, and keep doing till I is less than j. I plus and j minus minus we will take care inside the loop. So essentially what you do see is, what I have done is initialize I and j with start and last element of array. Until what time we will continue? Imagine if array was 1 to 5 and we were looking for a sum of 8. I will be here, j will be here. Sum is 6 right now. So what we will do is we move I forward. So I comes here. Now the sum of 5 and 2 is 7, still less than our value. So we will change our I to move here. Now once I and j meet at a point, they meet, that's where we stop and we say 8 cannot be achieved as a sum, right? That's where this condition is coming from, that we can continue only till the time I is less than j. If I crosses j, that means the sum is not even found. Right? So this is an important thing to keep in mind. So now we have put the condition. So we say if a of I plus a of j, if these two values that we have are greater than the sum we are looking for. So if the sum we are looking for, if these two values are greater than that, so what we do? We say j minus minus. So it is like decrement j. Right? Else if we say ai plus aj is less than sum, so the value that we are getting right now, if it is less than the sum we are looking for, we increment I, because incrementing I will increase it. Otherwise, in last case, what is the third case possible? Either this sum will be greater than this, or this will be less than sum, or this will be equal. In that case, we can simply say return true. That means we have found a sum which is equal to sum. So in that case, we can confidently return true. Now once this for loop is over, when we come to this step, we can simply say return false. That means this loop will break when I and j cross each other. In that case, we do not find the sum. Okay, so this is conversion of our approach to code. So clean code wise, if you look at it, is this. Now many people, what they do, they write as the first condition as ai plus aj. If this is equal to sum, we can simply say return true. And we can make other two cases as else if cases. So we can say else if this, and last case is we can simply leave it to else, because that is only one case. This is another way of writing the same program, because if sum is obtained, return true. If it is greater, decrement j, otherwise increment I. Right, so this is the approach 2, and you see that in the code. Now let's try to run this code and see whether it gives us the right answer or not. So what I'll do is I'll say gcc being0.c. So this is compiling our code, and when we compile our code, it generates a file a.exe. So let's run a.exe, hit enter, and now we see the answer being printed as yes. Now let's go back and change this sum to some other value. So let's say if I'm searching for a sum of 3000, we know this 3000 sum we are not going to get, but still we are modifying the program to see whether it will give no also as an answer or not. So we compile the code again, we run it again, and this time we see it is printing no. Now we can try it with various inputs. Now the other approach for people who are curious to know how we would convert the other approach into code is, there we were analyzing every pair. So what we can do is outer loop, we can say for I0, I less than n minus 1, I plus plus. The reason we are putting n minus 1 is because for last element we will not have a pair, so we are stopping just before that. So imagine if array is 1 2 3, first pair we will make 1 2, then we will make 1 and 3. These are two pairs. The last pair we will make as 2 3, because after 3 there is no other element, so there will be no pair. So this is less than n minus 1. Same way we say for int j is equal to, next element will start from the next index of I, j less than n, j plus plus. So this is our second loop. Now inside these two loops we can examine if ai plus aj is equal to given sum. If this is the true, then we say return true. Otherwise, we do not return false here, because we have to, in this loop, all other pairs will be generated. We keep examining all the pairs, and once we are done, we can say return false. Because if we did not find any pair in these two loops, then we return false. So this I will call it as naive approach. This will also give the correct solution, correct answer, but this approach is going to take more time than the previous approach. So two-pointer approach is more optimized, but let's still run the naive approach and see whether this gives us correct answer or not. One minor correction here is we have to take an minus 1, because that's the size of the array. Here also we have to use an. So this is a minor fix that we have to do. Now we can go and compile this code. So let's compile the code. GCC being 0.c, and let's run the code. If we run it with the correct value, let's say 144, compile again, run again, and this time we say yes. So these are the two approaches, and this is the more optimized approach.